Right, so, you know, a lot of you compete on a regular basis. You might compete in track, you might compete in wrestling, you might compete with your siblings for the last piece of cake. I don't know what you're in competition for. But if you're competing, you want to be just a little bit better, a little bit faster, a little bit tougher, maybe a little bit more ruthless. A friend of mine always swore that that was why her little brother got all the cake, because he was really ruthless. And the rest of them would put a note on the last piece of cake in the refrigerator that said, you know, I spit on this, Chrissy. So to save it for herself. And she said the problem with Danny, her little brother, was he didn't care. He'd eat it anyway. So you couldn't win. So in a competition for the last piece of cake, he won because he was just a little more ruthless. He just didn't care. If you're a little bit faster, a little bit tougher, a little bit bigger, a little bit sneakier, a little bit better camouflaged, you might be the one who outcompetes someone else. Okay, so competition is what happens when two different species need the same things, when their niches overlap, when they need to make use of the same resources. And it usually happens mostly between species that are closely related, because closely related species tend to have the most similar needs. And remind me, keep reminding me, I want to come back to that idea of closely related that you brought up. So I'm circling that to remind myself. I'll let you copy this. How many types of squirrels do we have in Ohio?
25.
25, okay. I hear 25. Do I hear another number? 3. Do I hear another number? I'm just taking a survey. 2. Do I hear any other numbers? 4. 7. 562. That's a number. We don't have that many kinds of squirrels in Ohio. Okay. So we have 2, 3, 4, 7, and what was
25.
25. Okay. Which of those do you think is the actual value? 3. 3. We actually have 3 species of squirrels in Ohio. And what I have here is a picture of 2 of the 3 that we have. The other ones are the little teeny tiny red squirrels, sometimes called pine squirrels. They're adorable. They're like the size of a chipmunk, and they have a distinctly reddish-brown back, and their bellies are white.
One of the ones that usually come out black sometimes.
That's this guy. That's the so. Does anybody know? Let's talk about this squirrel first. Anybody know what that one's called? It's in a tree. It's a tree squirrel. This is a fox squirrel. They sometimes get called a beefsteak squirrel because if you like to eat squirrel, my cousin, when we were kids, my cousin always hunted squirrels. And fox squirrels are the ones that actually have some meat on their bones. I mean, a fox squirrel can go 3.5 pounds. You know, a little red squirrel is not something you're going to eat. By the time you clean it, there's nothing left. But a fox squirrel you can actually make a meal out of. The other kind, this one, is called a gray squirrel. And what's funny, anytime we have a species whose name includes a color, you almost can guarantee there are some exceptions to the rule. Gray squirrels come in 3 colors. One of those colors is gray, obviously. Gray squirrels have a black color phase. So the black squirrels that you sometimes see are just one. I mean, humans come in different shades. So do gray squirrels. So gray squirrels have a reddish color, a gray color, and a black color. Those are the 3 color phases of the gray squirrel. And they're smaller than the fox squirrel, but bigger than the little pine squirrel, the red squirrel.
Is there a reddish color? Kind of the same color as the fox squirrel?
It's similar. The big difference is that in the gray squirrel, their bellies are always whitish, where in the fox squirrel, their belly is reddish. So in the fox squirrel, they're more similar in color front and back. The gray squirrels always have that contrasting lighter belly. So whether the gray squirrel is reddish, grayish, or black, they're going to have a pale belly. And then the pine squirrel, which is, like I said, you cannot mistake a pine squirrel or red squirrel for anything else because they're teeny tiny little squirrels. We've got a family of them living in the tree in my backyard, and they're so darn cute. And I'm not one who gets all excited about like, oh, how cute it is. I'm pretty realistic about wildlife. But like these guys are just adorable. They're these like tiny little chattery things that come out and yell at my dog. And they sit on a branch and go, it's kind of funny. I get some entertainment out of it. Okay, these two species are closely related. They want similar things. What do squirrels want?
Nuts.
Nuts. What else? Pardon? Yeah, pine cones. They'll strip pine cones for the nuts that are inside them.
Shelter.
Shelter. What else do they want?
Mates.
Mates. What else do they want?
Not to die.
Not to die. Yeah, sex and not dying. That's what biology is about. Making babies, not dying. Making sure your babies don't die. They want food, and they eat similar things. They eat acorns, they eat walnuts, hickory nuts, they eat pine cones. We talked about this briefly. We used the term mast, and that's food sources like nuts in the wild are called mast. So both of these squirrel species want mast. They both want places to be safe. They want to not die. They both want places for their babies to be safe. They want their babies to not die. So where do squirrels tend to find safety? In little nests that they make in the ground?
In a tree.
Trees, yeah. They want spaces in trees. And they want the acorns and the pine cones and the hickory nuts and the walnuts and the, let's see, what am I missing? Beech nuts that are growing. And they want spaces to nest. How do these two species both manage to hang on in Ohio when, frankly, there's a limited number of nuts and tree spaces and pine cones and all that?
They compete.
Well, they're competing for sure. How are they both hanging on? How come one doesn't drive the other one to extinction? How can we have three species of squirrel all living? Now, you know, the little red squirrels, the little teeny tiny cuties, obviously they might have slightly different needs. They're a lot smaller, so they might not need the same nesting places. These guys aren't that different in size. Gray squirrels are a little bit smaller, but not that much. Yeah. Okay, so that would be one strategy, is maybe that they're active at different times of the year. Now, when does the big nut crop come? When do all the walnuts and the hickory nuts and the beech nuts and everything else? Is that in the spring?
No, the fall.
Yeah, in the fall. In the fall is the big harvest time. Fall is the time to get fat. Get as fat as you possibly can, unless you're a wrestler, so that you're storing up calories in the form of your own body fat for the winter when you're not going to be able to find food. Either get fat or hide food, or do both, if you can manage it. Okay, so these two are in head-to-head competition. They want similar stuff. We still haven't answered the question of how these two squirrel species compete, but what I want you to think about is the fact that competition changes communities. We're talking about community ecology here. And that when species compete, some species may not be able to compete. They're not faster or tougher or stronger or better camouflaged or more vicious. And that whole sex and not dying thing, they don't do it very well. They don't manage the whole making babies, not dying, and making sure your babies don't die. And if you're not good at the whole making babies, making sure your babies don't die, making sure you don't die before you can help your babies, your species dies out. Do you remember what this was called? We talked about this species in the evolution unit. What was that? It was a whale. Yeah, it was a whale ancestor. This was morphed. Basilosaurus. I didn't really expect, heck, I could barely remember those. Basilosaurus. Do we have these in the oceans today? No. Because the aquatic community, the marine community, was changed by competition. Basilosaurus couldn't compete. They were voted off the island. They went extinct.
Those are the species right before the final.
That was the one. So this was the really massive one. And, you would think like this big, massive predator species would make it. But the little Durodons, who were more like dolphin-sized, were actually the ones that give rise to modern whale species. So yeah, this was the second to the last one that they talked about. And I think there were probably other intermediate species, but Basilosaurus died out.
They're the closest to the modern.
Well, they looked like it to us, but they're actually not an ancestor of the modern whale. So Durodon that doesn't look like a modern whale to us was actually the ancestor of the modern whale, because these guys all died out. They were not good at the whole sex and not dying thing. So competition changes the face of a community. Yeah, that's a good point too. Other things can change the face of a community. Parasites can change the face of a community. If you think about the Galapagos piece, how did parasites change the face of the Galapagos finch community? Yeah, the large tree finch went extinct because of pressure from that parasite. Competition can do the same thing. Competition can drive a species to extinction. Okay, competitive exclusion. This is when one species is essentially voted off the island. When one species is eliminated from a community because of competition for a limited resource. The more efficient predator wins. And we could put in here also the sneakier prey wins. Basically, the better adapted species wins. So here's the question, coming back to that idea of generalists and specialists. If you've got two species that are competing head-to-head, but one of them is really specialized and the other is more of a generalist, who is more likely to survive?
Generalist.
Yeah. Generalists thrive. Generalists tend to thrive because they are flexible. Specialists are at much higher risk of going extinct every single time. There are some life lessons for that. Be a generalist, don't be a specialist. But yeah, the better adapted species is the one that survives. Okay. Competition can also change species. Species can evolve over generations to use different resources, Gesundheit, so that they're not having to compete as hard. And this was in the crash course video we watched, this was where he talked about everybody wins a little bit. Everybody gets some success. Nobody has to go extinct. It's kind of like a compromise. Resource partitioning. So this is one of those ways that everybody can survive a little bit. When you have similar species living side by side, living in the same environment, needing the same resources or similar resources, they can sometimes find ways to only use portions of those resources. And this was the classic study, and I didn't realize how classic it was. It's one of those things, as a biologist, I've always known about the concept. I wasn't born knowing it, but, all through college, all through all kinds of things, you talk about resource partitioning, you talk about the fact that species do this. I didn't realize that this was not understood until the 1950s, that this was a relatively new idea in ecology. And then it comes out of the work on these 5 species of warbler. I'll let you copy. I'll shut up. Okay, so we will finish up resource partitioning. This is where we will start tomorrow.